Distance formula is a formula that we can use to find the distance between points. So distance formula, and if you're going to use this, you do have to memorize it. It's d, which stands for distance, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So the x and y refer to points on a coordinate plane. So looking at this example, it's asking us to use distance formula to determine the distance between the points. So first thing I need to do is get the 2 points. Well, point A, if we look at point A, the coordinates of point A are -5, 6. And the coordinates of B is 3, -4. So my two coordinates is -5, 6, which I'm going to call x1, y1. And then my other point is 3, -4, which I'm going to call x2, y2. So plugging into the distance formula, I'm going to plug in -5 for x1. I'm going to plug in 6 for y1. I'm going to plug in 3 for x2. And I'm going to plug in -4 for y2. So plugging directly into our formula, you end up with d equals the square root. x2 is 3, so it's going to be 3 minus -5 plus y2, -4 minus 6 squared. All right, so now we just have to simplify. So what I would recommend that you do is, if you're not very good with positives and negatives, go ahead and use your calculator. So first I'm going to do is inside the parentheses. So 3 minus -5 is 8. And then -4 minus 6 is -10. All right, simplifying a little bit more, so now we do the exponent. So 8 squared is 64. -10 squared is, -10 times -10 is 100. And then last thing we do is we add those together. So for these problems, I do want you to give me 2 answers. I want you to give me this answer, which is the exact answer. And then I want you to put that in your calculator to give me an approximate answer. So the square root of 164, when you put it in your calculator, you should end up with 12.8062, and it goes on for a while. So I only want you to round to 2 numbers after the decimal. The symbol we use for approximate is a squiggly equal sign like that. So D is approximately 12.8, and then it's 806. So since the number after 0 is higher than 5, we round up. So 12.81. This we call our approximate answer. All right, so that's how you do distance formula using a coordinate plane. So you can also use distance formula when you're just given the coordinates, such as the problem directly to the right. In this case, we already have x1, y1, and I have x2, y2. So now all I'm going to do is plug it directly into distance formula. So I'm just going to write out distance formula again. It's the square root of x2 minus x1 squared and y2 minus y1 squared. So using distance formula, I'm going to plug in 5 for x1. I'm going to plug in -4 for y1. I'm going to plug in -2 for x2. And I'm going to plug in 5 for y2. So plugging into the distance formula, we get it's going to be -2 minus 5 squared plus 5 minus -4. Okay, so all I did there was plug in x1, y1, x2, and y2. All right, next thing we do is we simplify inside the parentheses. So -2 minus 5, that's -7. And then we have 5 minus -4, which is +9. Okay, then we simplify the parentheses, or the exponents. So -7 squared is 49, and 9 squared is 81. So then we just add those together. You end up with the square root of 130. So this is my exact answer, the answer with the square root. To get my approximate, we put square root of 130 in our calculator. So you get 11.401, so it's going to be approximately 11.40. All right, so that's distance formula. So there's another way you could find the distance between 2 points, and that's Pythagorean theorem. So this problem right here is identical to this problem, so I'm just going to show you a different way of doing it. Well, Pythagorean theorem, you need a right triangle, okay? And Pythagorean theorem is a squared plus b squared equals c squared, okay? These are the legs, and this is the hypotenuse, which we're going to highlight in yellow. Okay, so looking at this picture here, we don't see a right triangle, but what you can do is you can turn this line into a right triangle. And the way you do that is you start at one point and you go straight down until you reach the bottom of the line, and then you go straight across until you reach the other point. So what I've done is I've turned this into a right triangle. I have my hypotenuse, and I have my legs. These are my legs. So now I can use Pythagorean theorem to solve for the length of AB. So first thing we need to do is count the side lengths. Well, to count the side lengths, you just count the boxes between the points. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this length is 10. And then we can do the same thing across. We're going to count the boxes between the points. So 1, 2, 3, 4, 5, 6, 7, 8. So this leg is 8. So now I have A and B. There's A, and there's B, and we're just going to plug into Pythagorean theorem. So it's just going to be 10 squared plus 8 squared, and that's going to give us c squared. Well, 10 squared is 100. 8 squared is 64. Next thing we do is we add these two together, so c squared is 164. And the very last step, to get c by itself, to undo that exponent, we take the square root of both sides. So c is the square root of 164. That's my exact answer. To get the approximate, we put it in our calculator. And you should get 12.81. So basically what I did is I just showed you two different ways of doing the exact same problem. When you're given a line on a coordinate plane, you can use distance formula to solve for the length, or you can use Pythagorean theorem to solve for the length. Okay, so you can also actually use Pythagorean theorem even if there is no picture. So this problem right here is similar to the previous one, but I'm going to show you how to use Pythagorean theorem for this one. Okay, and what I call this method, I call it the stack and count method. Okay, so when we're finding the lengths of the legs, really what we're doing is we're finding the distance between the y values and finding the distance between the x values. So we're going to figure out how many steps between the x values and how many steps between the y values. And what I mean by steps is I mean if we were looking at a number line, how far away are those 2 points, okay? So looking at my points, I call it stack and count because the way I do this is I stack up my points, so 3, -8, and then 6, 2. And then what I do is I figure out how far away is 3 from 6. Well, if we're thinking about a number line, if this is 3, to get to 6, we have to figure out how many steps we're going to take. So that's 3, 4, 5, 6. So that would put us at 6, and we took 1, 2, 3 steps. So the distance between 3 and 6, or the distance between those x values, would be 3. If we were to graph this, the number of boxes on a graph between 3 and 6 would be 3. Okay, then looking on the other side, the distance between -8 and 2, again, if we were to look at a number line here, if we start at -8 and we're going all the way to 2, it's -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2. So then we just need to figure out how many steps we took. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 total steps between -8 and 2. I do advise that you look on a number line. It'll help you for this. So for this one, since we're talking distance between points, we don't really care if we're going to the right or to the left. Either way, distance is always positive. So this becomes your A in Pythagorean theorem, and this becomes your B in Pythagorean theorem, and now we can actually plug it in to Pythagorean theorem. A squared plus B squared equals C squared. So I'm going to plug in 3 for A. I'm going to plug in 10 for B, and that's going to give me the distance. All right, so it's going to be 3 squared plus 10 squared is equal to C squared. So 3 squared is 9, 10 squared is 100. Then we're going to add these two together. So C squared is 109. And then the last step of Pythagorean theorem is we take the square root. So C is the square root of 109. This is my exact answer. To get my approximate, I put that in my calculator. Square root of 109 is 10.440, so it's going to be about 10.44. Okay. So now let's look at just some regular Pythagorean theorem problems where we're given a triangle. So looking at this one, I have my two sides, so this is A and this might be B. So it actually doesn't matter which side's A, which side's B. And then this side right here is my hypotenuse, this is C. So using Pythagorean theorem, it's going to be 5.6 squared plus x squared is equal to 10.2 squared. So this one's a little bit different because we're given the hypotenuse and we're solving for a leg. So we just do a little bit of algebra. So I'm going to square 5.6. That's 31.36. And then 10.2 squared is 104.04. And then for this one, to get x by itself, we got to subtract 31.36 from both sides. That's 72.68. Last step Pythagorean theorem is you have to take the square root. So my exact answer is square root of 72.68. To get my approximate, put it in my calculator, and you should get x is approximately 8.53. All right, so last example, this is a kind of like a word problem, but we're going to draw a picture. So it says, from where you are standing, you walk 5 feet forward. So if I'm standing right here, I walk 5 feet forward. Then I turn right and walk 9 feet. So if I turn right and walk 9 feet, I want to know how far away am I from my starting point? Well, if this is where I started, this is what I'm looking for. So I'm looking for that distance right here. Well, walking this direction, I formed a right triangle, so I can use Pythagorean theorem. What I'm solving for in this problem is the hypotenuse. Okay, so now that my picture's drawn, now I can just apply Pythagorean theorem. It's just going to be 5 squared plus 9 squared is equal to x squared. Pythagorean theorem, we need to make sure the hypotenuse is always by itself. So 5 squared is 25, 9 squared is 81. Then we're going to add those together. You get 106. Last step, take the square root of both sides. So there's my exact answer. To get my approximate, we use our calculator, square root of 106. You get it's approximately 10.295. That means I'm going to round the 29 up to 30. Okay, now I'm going to go over a couple of the practice problems. So looking at number 2, I'm finding the distance. I can use Pythagorean theorem or distance formula. So for this one, I prefer using Pythagorean theorem, so I'm going to turn this into a triangle. And it's 1, 2, 3, 4, 5, 6. And this is 1, 2, 3. So using Pythagorean theorem, it's going to be 6 squared plus 3 squared equals c squared. So 6 squared is 36. 3 squared is 9. So 36 plus 9 is 45. And then I'm going to take the square root of both sides. So the exact answer is square root of 45. To get the approximate, I'm going to put that in my calculator. And it's 6.709, so 6.71. Okay, looking at number 3, it's just a straight up Pythagorean theorem problem. 11 is my hypotenuse. So setting this up, it's going to be x squared plus 6.9 squared equals 11 squared. Leg squared plus leg squared equals hypotenuse squared. And now I'm just going to solve. So it's x squared, 6.9 squared is 47.61. 11 squared is 121. And then remember, when we're solving for a leg, we got to subtract. So 121 minus 47.61 is 73.39. And then we're going to take the square root of both sides. So my exact answer is square root of 73.39. And we put that in our calculator. We get approximately 8.566, so 8.57. Okay, looking at number 7, it's a word problem. It says the bottom of a ladder must be placed 3 feet from the wall. So I'm going to draw my wall and the ground, and I'm going to draw my ladder leaning against the wall. So 3 feet from the wall is on the ground, and it tells me that the ladder is 12 feet long. We want to know how far above the ground does the ladder touch the wall. So we're solving for this length right here, which is a leg. So using Pythagorean Theorem, it's going to be leg squared plus leg squared, so x squared plus 3 squared equals the hypotenuse squared. 3 squared is 9, and 12 squared is 144. And then to solve, we're going to subtract 9. So x squared is 135. And then we're going to take the square root of both sides. So my exact answer is square root of 135. And then to get my approximate, we put that in our calculator, you get 11.62. Okay. Now we're going to do number 9. We're finding the distance between the points, and we can either use distance formula or Pythagorean theorem. So I'm going to, like I said, I prefer Pythagorean theorem, so I'm going to use that method. Remember, when we're given points, I call this method stack and count. So we're basically counting the distance between the x values and counting the distance between the y values. So going from -8 to 3, that's 11 steps. Going between -5 and -1, that's 4 steps. And remember that these numbers are always just going to be positive because distance is always positive. So now I have my 2 legs. Now I can use Pythagorean theorem. So this is essentially a triangle that's 11 and 4, like this. All right, using Pythagorean theorem, it's 11 squared plus 4 squared equals c squared. 11 squared is 121, 4 squared is 16. And then we just add 137. And now last step, take the square root of both sides. I have my exact answer. To get my approximate, we just put that in our calculator, square root of 137. It's 11.70 approximately.